Hey, I've got an idea. Go away. It's that time of the night where my brain simply won't leave things alone. Hey, I think we can beat Doug. Leave me sleep. No, really, this is going to be great. Here are the scores from last night's Dominion. Yes, we're so competitive, we track our scores on a whiteboard. As you can see, 3 of us tied for 2 games each. So the winner was decided by totaling up all of our individual points. But if you look at the totals for each game, you can see what's eating my brain. Doug's games in particular are high-scoring games, whereas mine are relatively low, 326 points versus 142. What if we converted the points to percentages? That would be fairer, right? And wouldn't hurt if maybe changed the outcome? Fine, brain. Let's get this over with. First, let's put these scores into a CSV file so we can play around with them. Player names at the top, followed by the scores. Next, let's write some code to read them in. Go away with your Excel. Only real programming here. Now, let's create an outline of what we need to do. We need to read the data in, do some calculations, and show the final result. For the calculations, we want the percentages. To do that, we'll get the total for each game, then divide each of the individual scores by that total to get the percentage. Then we'll sum up the total points for each player to find the actual winner. Let's just drop in some code here to help us see what we've got. That looks good. 3 a.m. meet and create anything as elegant as this. Now, we could do this in pure Python. Calculating the totals is pretty straightforward, but once you get to the point of actually calculating the individual scores, things get a little bit more complicated. At 3 a.m., this is starting to hurt my head. How do we simplify this? What if we take a crack at it with Numpy instead? For this, I'm also going to break out the Numpy Speedsheet, which is really going to help me out. The first step is obviously import Numpy. With Numpy, we're going to have to change how we read the CSV file. That's easy, just look it up on the Speedsheet. We have a header in our CSV file, so we're going to pick the second choice. This will leave our data in a Numpy array, copy-paste. The next thing we have to do is to calculate the total for each game. What does Numpy have for calculating totals? We have 2 options here. We don't need a cumulative total, so we'll pick the second option and use the sum function. Well, that gave us the absolute total, not exactly what we're looking for, but Numpy has this axis parameter that's going to tell the sum function exactly what to do. So what should it be set to? The Speedsheet's going to help us out here. Typing in axes will give you a visual representation of what we want to do. We have a 2-dimensional array, and we want to go across, so we're going to pick axis equal to 1. Much better. Now let's calculate the individual scores. The calculation for that is the score divided by the total for that game. Here's where Numpy really begins to shine. For instance, if you want to add 1 to each element inside an array, all you have to do is type array plus 1. That's it. So Numpy will take an operator and allow it to be applied on all the individual elements inside an array. And it doesn't have to be an array and a single value. It will do operations from array to array as well. I'm not going to geek out over this here, but this totally blew my mind when I saw it first. This is why Numpy is pure gold. So we can divide our scores by our newly calculated total. Whoops, I just said we could do this. What happened? Alright, arrays need to follow some rules before they can operate together. They need to be broadcast compatible, which broadly speaking means working from the bottom dimension upwards, dimensions must be of the same size or of size 1. We can easily find out the dimensions or shape of our arrays. Just type getShape here, put that into our code. What we find is our totals array is the wrong shape to work with our game scores. Let me explain. Looking at our 2 arrays, we can see the game scores has a dimensional shape of 6 by 4 versus the totals, which has a 1-dimensional shape of 6. It's pretty obvious we have a bit of a problem here. We need to turn our total into a compatible shape, one that will apply it along the axis 0 or vertical axis of the game scores. We need an array of shape 6 by 1. Numpy makes this really easy to fix. We're going to use the reshape function. And the values we need to set are the game count, 1. That 1 is going to give us that single element dimension that we need at the bottom. As for game count, Numpy gives us a little trick so that we don't actually have to worry about what the game count is. Instead, just put -1 and Numpy will calculate the rest. And we got all that in one elegant line. Now that we have the game totals, let's get back to updating our individual scores. So these numbers look a little odd, but if I multiply them by 100, you can see they're just percentages. Finally, we need to calculate the only thing that really matters, the player totals. Here we want to sum in the opposite direction to how we calculated the game totals. So we'll need to use the sum on axis 0. One more step. Let's make these percentages. So let's divide by the game count. And the final step, show the results. Compare this to what you would have had to do if you just used plain Python. The Python code isn't huge, but it's triple the number of lines, and there are chunks of code in the middle and the end that took time to write and test, and these would take someone else time and effort to parse so they understand what is going on, and that person may be you 6 months from now when you need to make it. In contrast, using NumPy only requires 3 lines of code. Each was easy to put together, the math is crystal clear, and the overall intent is immediately obvious. Of course, using the Speedsheet made this a breeze, and all of this made 3 AM Tim and his brain much happier. Take that, Doug. You lose.
Thanks, brain. Can we go to sleep now?
Sure. What do you think about doing this with pandas?
Ugh, go away.